Hello, hello! Here is the video going over your quiz review for sections 4.1 through 4.3. This video will cover solving systems by both graphing and substitution. So, number 1, is the point 3, -2 a solution to the following system? Now, a solution to the system is something that works for both equations. So what I'm going to do is I'm going to take this point, which is an x and a y, and I am going to plug it into both of the equations. So my first equation is y equals x minus 5. So where I see a y, I'm going to put -2. Where I see the x, I'm going to put 3. And what I want to do is I want to check to see that that gives me a true statement. So I'm going to go ahead and simplify this side. So I have -2 equals 3 minus 5 is also -2. So it does work for the first equation. Now let's double check to see if it works for the second equation. So for my second equation, which is 3x plus y equals -1, I'm going to replace my x with a 3 and my y with a -2. And I want to simplify this side to see if it ends up equaling -1. So 3 times 3 is 9 minus 2. 9 minus 2 is 7, which most definitely does not equal -1. So my answer for this is no. It is not a solution. So again, anytime you're checking to see if a point is a solution, you're taking that x value and the y value and plugging it into both equations. And it has to work for both equations. All right, solving by graphing. So what you want to do is you want to graph both of the lines. So I'm going to go ahead and use 2 different colors so you can see which line corresponds to which equation. So the one I circled in purple is y equals -2x plus 3. This equation is in slope-intercept form. My slope is -2, and my y-intercept is 3. I'm always going to begin at my y-intercept. I'm going to begin at my b, which is at 3. And my slope is -2. So I'm going to go down 2 over 1. Down 2 over 1, and I'm going to continue to plot points until I have filled my entire graph with all of these points. Now it seems a little tedious to plot every single point, but it makes your lines more accurate just in case if you only plot a couple of points and you draw your straight line, your line might be slightly skewed to where it's going through different points. Okay. So x equals 2. X equals 2 means I'm going to go to 2 on my x-axis. There's 2 on my x-axis. And x equals is going to be a vertical line. So I'm going to draw a vertical line through 2. And what I'm looking for is I am looking to see where my purple line and my green line intersect. And that is where I highlighted it in blue. That ordered pair is 2, -1, and that represents your solution to the system. I'm going to do the same thing for number 3. Y equals 3 means I'm going to go to 3 on my y-axis. Y equals a number is going to be a horizontal line, so I can go ahead and draw my horizontal line. And my next line is in slope-intercept form. So my slope is 3 and my y-intercept is -3. So I'm going to begin at my b at -3. Slope is 3, so I'm going to go up 3 over 1. And I'm going to continue to plot all of my points until I find that intersection, which I just did. But I'm just going to go ahead and plot every single point just because I like accurate graphs. I'm going to go ahead and draw my green line, and where my purple line and my green line intersect, that is my solution. And the ordered pair for that is 2, 3. All right, let's do some more. So my first line, slope-intercept form, m is 2, y-intercept is -4. So I'm going to go down to -4 on my y-axis, go up 2 over 1, up 2 over 1, and I'm going to continue until I have plotted, oop, that was in the wrong spot, plotted every point that fits on my graph. There's my purple line. Well, that wasn't drawn very well. Let's try again. There we go. And let's do my second one. Slope is 2 again. Y-intercept is 5. So I'm going to start at 5. Slope is 2, so I'm going to go up 2 over 1. Up 2 over 1, and you can kind of already see what's happening with these two lines. These two lines are actually parallel. Parallel lines will never intersect, so this system will not have a solution because they'll never intersect. So solution, none. I can also tell by my equation that these are going to be parallel lines because if you look at your slopes are exactly the same. And you do have different y-intercepts, so your starting points are going to be different, which is going to result in two parallel lines. Okay, number 5. My slope is -2/3. Y-intercept is 1. So I'm going to start at 1 on my y-axis, of course. Slope is -2/3, so I'm going to go down 2 over 3, down 2 over 3, and I'm going to continue, go in the opposite direction as well, and I can draw my purple line. Oh, there we go. And let's do the green one. Okay, so this equation is not in slope-intercept form. So what I want to do first is I actually want to get it into slope-intercept form because I think that graphs a little more accurately when we're trying to solve a system. So I just rewrote it at the bottom. It is a 2-step process to get your y by itself. Step number 1 is to move the x. So I'm going to start by subtracting 2x from both sides. And I'm subtracting because my original 2x was positive. And anytime you're moving across the equal sign, you are always using the opposite operations. As you can see, when I rewrote it with my x first because that's how we see slope-intercept form. And in front of my y, I originally had a minus. So I like to write it as a -1 because that reminds me that for my second step, I still need to divide. So now I'm going to divide everything by -1. So I get y equals -2 divided by -1 is +2. 7 divided by -1 is -7. And now that this is in slope-intercept form, my slope is 2 and my y-intercept is -7. I can go ahead and graph. So I'm going to start at -7. I'm going to go up 2 over 1, up 2 over 1, and there we go. We have our intersection points. So I'm going to go ahead and draw my green line. And my intersection point was right here at 1, 2, 3, -1. So again, for this particular question, I did have to get that second equation into slope-intercept form, but that was a 2-step process that we did down here with moving the x followed by dividing by whatever number was in front of the y. Okay, switching gears. So now we are going to solve by substitution. Now what you are looking for when you're solving by substitution is you are always looking for an isolated variable in one of your equations. So I'm looking for an equation that says x equals something or y equals something. So if I look at my first system, I have y equals negative x plus 8. So what I like to do is I like to circle what it equals. I'm going to draw an arrow to where I'm going to substitute it. So I'm always taking one equation and substituting into the other equation. So I'm going to go ahead and rewrite my second equation. If there's no number, it's a 1, so I'm going to write this as negative 1x plus 2. But instead of y, I'm going to put my equation that I circled, which is negative 1x plus 8 equals 7. So now if I look at the equation that I have written down, my equation is only in terms of x's, so I can take this and solve for x. So I do have this 2 in front of my parentheses, so I'm going to go ahead and distribute. So I have negative 1x plus 2 times negative 1x is negative 2x. I'm going to go ahead and change that to a minus 2x plus 16 equals 7. I can combine like terms. So negative 1 minus 2x is negative 3x plus 16 equals 7. Subtract 16 from both sides. That gives me negative 3x equals negative 9. Divide by negative 3 and you get x equals 3. Now I still need to solve for y. So in order to solve for y, what I'm going to do is I'm going to take this value of x and I'm going to plug it back in to the equation that I circled. So I have y equals negative x, so that would be negative 3 plus 8, which is 5. My solution should be written as an ordered pair, so my x coordinate is 3, y coordinate is 5. For my next one, I'm going to do the same exact thing. So I'm circling what y equals, drawing an arrow to where the substitution is going to happen. I'm going to rewrite my first equation, but instead of y, I'm writing negative 1x plus 4. And I'm going to continue to rewrite the equation, and now I have an equation with just x's. I can distribute, so negative 3x plus 12 plus 3x equals 14. I can combine like terms. I don't know where this line came from. There we go. So negative 3x plus 3x is 0, so that's going to cancel out. So I'm left with 12 equals 14. Well, does 12 equal 14? Of course not. That's a stupid question. So that means this one has no solution. And you can see at the top of the box that it was a no solution kind of problem. When there's no solution or infinitely many solutions, what's going to happen is that your x's or y's, whatever your variable is, they are going to cancel out. And if you end up with a statement that is false, that is no solution. And if you end up with a statement that's true, which we'll see for the next one, that'll be infinite solutions. All right, so circling, drawing my arrow, rewriting. Instead of y, I'm going to replace it with x minus 5. There we go. And let's distribute. Be very, very careful with this distribution because right now you do have a negative 3. So we need to distribute the negative 3. So I have 3x. Negative 3 times x is negative 3x. Negative 3 times negative 5 is a positive 15 equals 15. And once again, my x's are going to cancel, and that leaves me with 15 equals 15, which is true. So that means this one is infinitely many solutions. I just like to write infinite solutions. It's one less word. Some people like to use the infinity symbol instead. But as long as you're indicating that it's infinite solutions, you are good. All right, next up, more substitution practice. Number 6, I am going to circle, draw an arrow. I'm going to go ahead and do that for all of these, 6, 7, and 8. Circle, draw an arrow, and rewrite. So I'm going to rewrite my second equation. Instead of y, I'm going to replace it with negative 3x plus 1. I do have this negative in front of my y, so I'm going to write that as negative 1 times, and I'm going to make my substitution. And from there, I can go ahead and solve. Distribute. So I have 3x minus 5 equals negative 1 times negative 3x is positive 3x minus 7. I have variables on both sides, so I'm going to pick one of them to move. I'm going to subtract 3x from both sides. Oh, look at that. My x's cancel. I have negative 5 equals negative 7, which is false. So this one is no solution. All right, number 7. Going to rewrite my second equation. Since I do have that minus, I'm going to write it as minus 1, and I'm going to substitute my y with that 2x minus 8 equals 10. And distribute. So I have 3x minus 2x, since I'm distributing the negative 1. Negative 1 times negative 8 is a positive 8 equals 10. Combine like terms, 3x minus 2x is 1x, plus 8 equals 10. Subtract 8 from both sides, that gives me x equals 2. Now that I have a value for x, I'm going to take that and plug it into my equation that I circled. So y equals 2 times x, but I now know that x is 2 minus 8. That gives me 4 minus 8, which is negative 4. My ordered pair, x first, and then y. So positive 2 and negative 4. All right, number 8, I already circled, I drew my arrow, so let's go ahead and rewrite. So I'm substituting my y for negative 1x plus 3. Let's go ahead and rewrite the rest of the equation. I've run out of space. There we go. I'm going to pick one of my x's to move. I'm going to go ahead and add 5x to both sides. Those cancel. Negative 1x plus 5x is 4x. Plus 3 equals negative 9. Subtract 3 from both sides. That gives me 4x equals negative 12. And divide by 4. So I get x equals, what is that? Negative 3. And of course, now that I know that x is negative 3, I'm going to plug it into my circled equation to solve for y. So I have negative 1 times x, which was negative 3. Be careful with these negatives. They're all over the place, so you kind of have to pay attention to what you're doing. Negative 1 times negative 3 is positive 3. 3 plus 3 is 6. Ordered pair, negative 3, 6. Awesome, let's do 3 more. Okay, circle, arrow, circle, arrow. Oh no, number 11, nothing is ready to be circled yet. So if you'll notice with number 11, there is a star next to it, which makes it a little bit more challenging. So we'll talk about number 11 once I finish up 9 and 10. So now I'm going to rewrite, but instead of x, I'm going to substitute it with y plus 5 minus 2y equals 7. Distribute. Whoops, I don't know why I put an equal sign, or minus. 2 times y is 2y, 2 times 5 is 10, minus 2y equals 7. Combine like terms, 2y minus 2y cancels out, so I have 10 equals 7, which of course is never going to equal 7. So this one is no solution. All right, let's keep going. Number 10. So I have 2, but of course instead of y, I'm going to substitute it with 7 minus 3x plus 6x equals 14. Distribute. 2 times 7 is 14. 2 times negative 3x is negative 6x plus 6x equals 14. Combine like terms. My x's are going to cancel again, but this time I end up with a true statement. 14 equals 14. So this is infinite solutions. By the way, if you were to have a graph that results in infinite solutions, what that ends up looking like is you end up just having one line because you end up graphing the same line twice. So I don't think we had that in this review as a direct question, but just in case you needed to know that, if you're solving by graphing and you end up graphing the same line twice, that would be infinite solutions. Okay, so let's talk about number 11. So number 11, I do not have a scenario yet where I have an equation that says x equals or y equals. All the other questions were already set up with an isolated variable, but this one is not the case. So what I want to do is I want to take one of these equations, and what I want to do is I want to solve for a variable. So I'm going to focus on the first equation to my system, and I'm actually going to solve for x because I want to get x by itself. It really does not matter which variable you choose to isolate, but I'm going to isolate x just because that's the first variable that I see. Now, in order to get x by itself, I need to move this y to the other side. And since I'm subtracting y, in order to move it to the other side, I need to add y to both sides. And what happens is I end up with the equation x equals y plus 9. And now it is set up to where the other systems were, where you have an isolated variable and you can make the substitution. So now I can rewrite my second equation, but of course instead of x, I can replace it with y plus 9. And from here, I can continue to solve. So 2 times y is 2y plus 18 plus y equals 6. I can combine these like terms. 2y plus y is 3y plus 18 equals 6. I'm going to subtract 18 from both sides. That gives me 3y equals negative 12. So y equals negative 4. And of course, I can take this, plug it back into my circled equation. So I have x equals y plus 9, but of course I now know that y is negative 4. And negative 4 plus 9 is 5. So my solution for this is 5, negative 4. All right, I hope this video helps you get prepared for your quiz. Good luck!